Welcome back to video lecture on pandas. We shall now be covering function applications. If we wish to apply our own function or function of other library to pandas objects, there are three methods that could be used depending upon whether we need to apply the function on entire data frame, row or column, or element wise. Okay, we shall now see these three methods. Okay. The first one is table-wise function application by using pipe method. Second is row or column-wise function application by using apply method. And the third one is element-wise function application by using apply map method. Okay, we'll start with the first one. Okay, now, custom operations can be performed by passing the function and the appropriate number of parameters as pipe arguments. Now, for example, say I have my data frame and I want to perform some operation on it. Okay, for example, I want to add some number to it. Okay, so and I've written a function for adding. Okay, now let's assume that this is my function. Okay, addition. Okay, and it is going to add some numbers to my data frame. Okay, so this is how the function definition is. Def addition number 1, number 2, number 3. It's accepting three parameters. Okay, and it's returning the addition of these three parameters. Now what I'll do is I'll create a data frame. Okay, say these are my values 1 to 3, 10, 20, 30 and 100, 200, 300. These are the values of my data frame. Okay, I'm creating my data frame, pd.data frame. Okay, and now what I'm doing is I'm using pipe. Okay, basically I want to add 2 and 3 to the elements of my data frame. Okay, so what I'll do is I'll write df.pipe addition. I have already written the function addition. Okay, it's accepting three parameters. First one is the data frame element, second is 2 and the third one is 3. Okay, so basically this is just to show you all how to pass two arguments. We could have easily written 5 over here instead of writing 2 and 3 separately. But just to show how to pass two arguments, I have taken this small example. So basically what the addition function is doing, it's taking three parameters and it is returning the addition. Okay, so what are those three parameters? The first parameter is the data frame element, second is 2 and the third is 3, and it's adding 2 and 3, that is 5, to the data elements of the data frame. Okay, let's have a look. Created another. Okay, so what I'll do is first I'll create a data frame. It's simple list of list. So this is my data frame. This is how it looks like. Okay, now what I'll do is I'll create the function. Okay, now I will use pipe. Okay, So what it has done, see, I'm passing 2 and 3. 2 and 3 means 5. So basically I'm adding 5 to all my elements. So 1 plus 5, 6, 2 plus 5, 7, 3 plus 5, 8, 10 plus 5, 15. Okay. So basically it has called addition on all the elements of the data frame. Okay. Let's move on to the second method. Functions can be applied along the axis of data frame using apply method. Okay, by default, the operation performs column wise, taking each column as an array element. It will be applied. See, if I want to apply some function, okay, I want to apply that function along an axis. Okay, it could be along the row or it could be along the column. Okay, then I will use df.apply. Okay, pipe is used for the entire data frame. If I want to do something across along a column or along a row, I will go for apply method. Okay, the syntax is very simple. First is you create a data frame, whatever data frame you want, you may create that. Next is you use apply. So you say df dot apply, okay, and whatever you want to apply. Now there is an extra argument here that we need to pass. If by default it is 0, by default axis is 0, that is by default it is along the column. Okay, but if I want it along a row, then I will have to specify axis is equal to 1. Okay, let's have a look. Okay, so basically what it has done, it has calculated mean. Okay, we have said df dot apply np dot mean. Okay, my np is actually, I have imported the numpy package. Okay, import numpy as np. I have already done that. Okay, so what I'm basically doing, I'm saying df dot apply np dot mean. Okay, so it is applying mean along the column. By default, it is along the column. So 1 plus 10 plus 100 divided by 3. Mean is nothing but average. Okay, so basically 111 triple 1 divided by 3 and it's returning you 37. Okay, so 222 divided by 3, it's returning you 74. 333 divided by 3, it's returning 111. Now, if I want it along row, okay, I will say axis is equal to 1. By default, axis is 0 if I want it along the row. Okay, so mean of 1, 2 and 3 is 2. Mean of 10, 20 and 30 is 20. And mean of 100, 200, 300 is 200. So what we have done is we have applied column wise or row. We can apply some method column wise or row wise. Okay, by default it is along a column. Okay, along a column, or you can say across rows. Okay, if you want to make it along a row or across columns, you will have to specify axis is equal to 1. Okay, moving on to the third method. Okay, if you want to apply a function to a data frame element wise, element by element, then we use apply map. See, pipe is used for applying the function to the entire data frame. Okay, apply is used for applying it across along a column or along a row, and apply map is used element wise. The syntax is simple. You just have to say df dot apply map, and whatever function you want to apply, you may. Okay, so let's have a look. Okay, I'll do one thing. So we'll use the same one. Okay, so as you can see, it has applied mean element wise. Here it was row wise or column wise, but here it is element wise. Therefore, it's returning mean of 1 is what? 1. Mean of 2 is 2. Mean of 3 is 3. Okay, so it's returning you the elements itself. Okay, I can, a better example could be say square. Okay, so what it is doing, it is calculating square of each and every element and it is displaying that. Let's move on to the next topic, that is reindexing. Reindexing changes the row labels and column labels of a data frame. That means we can change the row index and the column labels as well. Operations that can be performed through indexing are: first is reordering the existing data to match a new set of labels. Okay, we'll be reordering the existing data. Okay, and second one is inserting missing value NaN, not a number, markers in label locations where no data for the label exists. So wherever there is no match, NaN would be inserted over there. Okay, first of all, it will reorder the data, and secondly, wherever there is no match, it will put NaN. The syntax is simple. We create a data frame first and then we simply say df.reindex, and in brackets we pass the new index to it. Okay, a new object is produced. Obviously, a new object will be produced if there is no match, or if a new object is produced unless the new index is equivalent to the current one. If both the indices are same, then the new object won't be created. But if there is any difference in the index, then the new object would be created. Okay, let's take this example. Okay, first we are creating a variable called as index, wherein the names of browsers are there, like Firefox, Chrome, Safari. Okay, so this is my index. Okay, then we are creating a data frame. Okay, wherein it's a dictionary. Okay, so this is the key and these are the values. This is the key, another key, response time, and these are the values. Okay, and we are passing index to it. Okay, so basically this is the index. Okay, we are explicitly defining the index over here, which are the names of the browsers, and these are the corresponding values: HTTP status and response time. Okay, they are just some random values. Okay, and then if we create a new index, okay, this is the new index wherein some values are common. As we can see, Safari, I10 and Chrome. Safari, I10 and Chrome, these values are there in the new index as well. And there are certain new values also, like Ice, Vessel, Komodo Dragon. There are new values also. So what will happen, wherever there is a match, those values would be fetched, and wherever there is no match, NaN would be inserted. Not a number would be inserted. Okay. Now, suppose if we do not want to fill NaN, okay, what we can do is we can pass a parameter fill underscore value is equal to 0. Okay, so instead of NaN, 0 will be filled wherein the indices do not match. Okay, if you want to put some other value, some text, you can fill that as well by saying fill value is equal to missing. Again, instead of NaN, missing will be filled wherein the indices do not match. Okay, let's have a look at it. Okay, I'll just copy paste the data frame so that we don't waste time in typing. So I have copied, run it. Okay, so my data frame is created with the names of the browser as my row indices. Okay, these are my columns and these are the values. Okay, now I will create a new index. Okay, so I've created a new index. Okay, new underscore index. I'm storing some new indices in it. Okay, and then I'm saying df.reindex and I'm passing that new index to it. So as we can see, it has been changed. Okay, Safari, it has taken the same values. Okay, Ice Vessel, since it did not had any, there was no match. It's mentioning NaN. Okay, even for Komodo Dragon, NaN is there. I10, there is a match and therefore the values are inserted. For Chrome as well, there is a match and so the values are inserted. So this is how it will be. Now suppose I, instead of NaN, I want to write some, say maybe we can go for 0 or missing value, anything. Okay, so I will have to pass a parameter fill underscore value. Okay, so I can specify that. Okay, so instead of NaN now, 0 would be displayed. As we can see, instead of NaN, zeros are there. Similarly, if I want, instead of 0, I can specify some this as well, some text as well. Okay, so instead of 0, now the values are missing. Okay, so next is, there is one more parameter which we can pass. Okay, we can say method is equal to bfill, backward fill, forward fill, or nearest. Now when we say bfill, it means that use next valid observation to fill the gap. When we say ffill, it says propagate last valid observation forward. When we say nearest, it says use nearest valid observations to fill the gap. Let's take an example and see what do we mean by this. I've created a simple data frame here. Okay, so the indices are 1, 3, 5, 7, 9 odd numbers, and the values are also, I've kept the values same because it will be easy to understand. Okay, and I'm passing the index and creating a data frame like this. Okay, so for index 1 the value is 1, for 3 it is 3, for 5 it is 5. Okay, let us now re-index and use bfill. So I have created a new index. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm saying df.reindex and I'm passing the new index to it, and I'm saying method is equal to bfill. Okay, I'll run it. Let's see. Okay, so what it has done, what is bfill? Bfill means we use next valid observation to fill the gap. Okay, so for 2, the next valid observation is 3, and therefore 3 would come. Okay, for index 2. For 4, the next valid observation is 5, and therefore value of 5 would come over there. For 6, next valid observation 7, so value of 7 would come over there. Okay, now if I say method is equal to ffill. Okay, what is ffill? Propagate last valued observation forward. Okay, so for 2, the last valued observation is 1, and therefore 1 would be the value for 2. Similarly, for 4, the last valued observation is 3, and therefore 3 will come for 4, and so on. Okay, there is one more. See, we have bfill, ffill, and there is one more, nearest. What nearest does? Use nearest valid observations to fill gap. Okay, we'll change this to nearest now, and let's not change much. Okay, now now the method is equal to nearest. So 2 is actually near to both 1 and 3, but it's using 3. Okay, for 10, the value is 9 because the nearest one is 9. Similarly, for 11, the value is also 9 because the nearest one is 9. And it will so on. If we write 12 also, the nearest one would be 9, and therefore the value of 9 would appear for 12 as well. The next topic is sorting. There are two types of sorting available. One is by label, and the other one is by actual value. By label means by row index or by column names or column labels. This one is by actual values of the data frame. Okay, so let's start. Let us see sorting by index. Okay, that is, it will sort by index and not by value. It will sort the indices. Okay, now the syntax is simple. We create a data frame first, and then we simply say df dot sort underscore index. Okay, so it will sort according to index. Okay, let's have a look at it. Okay, so we have written the code for creating a data frame. Okay, we are actually creating a data frame by random values. Okay, we have passed the shape to the rand function. Okay, so we want 10 rows and 2 columns. Okay, and these are the indices. Okay, it's not ordered. Okay, and these are the column labels. Again, they are not ordered. Okay, and we say run. Okay, so the data frame is formed. Okay, now it's not ordered. Now if I want to order, okay, I'll simply say okay, so now it has sorted the data frame according to the index. It's an order now. See here, it wasn't ordered. Okay, 0 is here. Okay, now this is ordered. 0 1 2 3 4 5 6 7 8 9. Okay, now then next is if I want, by default it is ascending order. If I want it in descending order, I'll simply say ascending is equal to false. So it will sort according to, it will sort in descending order. Next is sorting the columns. This is row index. We are sorting according to row index. Now by default it is row. By default the axis is 0. That is, it sorts by row. But if we can change it to column, that is sorting by column index or column label, we simply have to say axis is equal to 1. Now let's take the same example and specify here axis is equal to 1. So now it will sort according to column. See, it is column 1 and column 2. Here it was column 2 and column 1, and now it is column 1 and column 2, and the row indices are not sorted. Basically it is sorted according to uh, column 1 and column 2. Okay, let's move on to the next. Sorting by values. That was sorting by index. The indices were sorted. Okay, now we have to sort according to values. Okay, it accepts one parameter. By is equal to the name of the column. Now it, you can have column, you can sort according to names. Okay, you can sort according to age, according to marks, according to rank. Okay, so we say df dot sort underscore values by is equal to the name of the column. Okay, there is one more thing. If we want to specify the algorithm for sorting, okay, we can specify that too. Merge sort, heap sort, quick sort, these are the values that we can pass. So we can say kind is equal to and then the name of the algorithm that we want. Okay, let's have a look. So now it is sorting according to column 1. So see, in 0 0.01, 0 0.16, 0 0.16, 0 0.32, 0 0.53, 0 0.54. It is sorting according to value. Okay, and we have specified according to column 1 values. So the respective column 2 values and the respective row indices would come. The next topic is working with text data. Pandas provide a set of string functions. These functions ignore the missing value or NaN values. Now, since these methods work with Python string functions, what we need to do first is convert the series object to string object and then perform the operation. Okay, so let's have a look. The first function is lower. Okay, what it does, it converts strings in the series to lowercase. This is the syntax for that. Okay, let's quickly see. Okay, I'll create a series first. Yeah, so I've created this series consisting of some names like Tom, Ricky, Jimmy, Priya, Darshini. Next is we'll see the functions one by one. Okay, the first function is lower. So what it does, convert strings in the series to lowercase. So all I have to do is specify, first convert the series to string. So s.str dot lower. Okay, so it will convert. Now as you all can see, this letter R was capital, but now it has been converted into lowercase. Similarly, we have another function called as upper, which will convert all to uppercase. Okay. Next is length. Length will give you the length of the string, compute string length. Okay, a simple function. So it will give you the string length. This is 3, this is 5, this is 5, this is 13. Okay, next is strip. Strip, what it does, it strips the white space from each string from both the sides. For example, let me change, see, I've added few spaces over here. I'm running this. Now as you can see, Tom has been shifted to left. Because there are some spaces over here. Now if I say strip, okay, now Tom, the white spaces have been removed. Okay, strip will remove the white spaces. Next is split. It splits each string with a given pattern. Now let's say, okay, I've specified space as my pattern. So it's separating according to the spaces because my pattern is space. Now for example, I say, okay, if I say this, so now what it will do, since I've specified space, so it has, see, all other examples, they do not have space in between. Okay, but if there is space, it will split the string with a given pattern. Okay, the next is concatenation. Okay, for that we use something called as cat, and uh, what it does, it concatenates the given series with the given separator. I can specify the separator and it will just concatenate, it will just add those string with the given separator. For example, I say cat and my separator is comma. Okay, or let's say underscore. So it's the error. I have to specify that it's a separator. Okay, so it has separated the strings by underscores. Next is contains pattern. Okay, so returns a boolean value true for each element if the substring contains in the element. If basically we pass a pattern to it, and in case if that string contains that particular pattern, then it returns a boolean value true. Okay, so let's see this. Contains, okay, and in bracket I will specify the pattern. Okay, for an example, let's say okay, I want to look in for this particular pattern let me run this. Okay, so for the first there is no so it's returning false, it's returning false. Here it's returning true because is over there. Here it's returning false. Okay, moving on to the next. The next function is replace. So what it does, it replaces the value A with the value B. Okay. Now for example, I want to replace mm with a single m. Okay. Okay. So here, as we can see, it has replaced mm with a single m. The next is repeat. So simple again, repeats each element with specified number of times. So I say three times. Okay. So it will repeat the elements three times. Okay, Ricky, 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 Jimmy, Jimmy, Jimmy. Next is count of pattern. Okay, so it returns count of appearance of pattern in each element. Okay, so let's say I want to count say A. Okay, so in the first there is one A, in second there is no A, 0, 0, and here there are two A's. Okay, so it will return me the count of particular pattern. Next is starts with and returns true if the element in the series starts with the pattern. Okay, so if my string starts with the pattern, so it will return true. Starts with let's say T. So for the first element, as we can see, it starts with T. So here it will return true, and for others it will return false. Next is similarly we have ends with. Okay, so returns true if the element in the series ends with the pattern. Next is find. Okay, find, it returns the first position of the first occurrence of the pattern. Okay, so if I say find, okay, and anything we can give any pattern. Okay, so it returns the first occurrence. Okay, here the first occurrence is at 0th index, so it's returning 0. Okay, there are no occurrences of T, so it's returning -1. Okay. Find all returns a list of all occurrence of the pattern. For example, if I say find all, say I. Okay, so here there is no I, here there is one I, here one, here three I's are there. So it will return me all the patterns. Returns a list of all occurrence of the pattern. Okay, next is swap case. Simple enough. It will simply swap the case. If it's lower, it will make it upper. If it's upper, it will make it lower. Now next is lower. Checks whether all characters in its string is lowercase or no, and it returns a boolean value. Okay, if all are in lowercase, it will say true. Otherwise, it will say false. Similarly, we have is upper, wherein if all the characters are in uppercase, it will return a true, or else it will return a false. The next one is numeric. It checks whether all characters in its string are numeric. Okay, let's do one thing. Let's change the string. So instead of words, let us use numbers. Okay, so I am changing the string, and what's my method is numeric. Okay, so since they are numeric, it's returning true. So to summarize, in today's video lecture, we saw how to apply functions, external functions to pandas objects. We saw how to re-indexing the data structures of pandas, how to sort the data according to index and according to value, and we saw some functions that we can use while working with text data. Thank you.